Hello everybody! Today's video is talk about the derivatives of logs and exponents and maximum and minimums. So these will be a few shortcuts that will help you be able to determine things that are useful while avoiding the huge long process that we've had to do in the past. Now, this has everything that you'll be needing for Wednesday's class. Hopefully you understand everything properly. If not, make sure to ask questions. But these are some nice, pretty straightforward things, so it shouldn't take too long. All right. First of all, the derivatives. If you have a function that's in the exponential form, so it's some set base number raised to a variable, all right? Then, when you take the derivative of it, it comes out nicely to the natural log of your base multiplied by your original function. So exponentials never actually fully change. They'll kind of stay with the same base exponential look. Now, if you notice, we're doing the natural log, which means if we have e to the x, well, what's the natural log of e? That's just 1. So e to the x, the derivative of that is just e to the x. It will never change. Now keep in mind, it is possible that you could have a chain rule set up, so that would follow through just like all the other regular derivatives. Now, if you're dealing with a log, well, this is the same type of thing, but you should know that exponentials and logs are inverses of each other. So you still have the natural log of your base, but it's in your denominator now, along with your variable. And besides that, logs are gone. So same situation, if you're dealing with base e, it just becomes 1 over x, and it just goes from there. All right, so that's just the derivatives of those two situations. Should be pretty straightforward. Let's take a look at an example. So I want you to find the derivative of the function f of x equals log base 3 of x plus x squared times 5 raised to the x. So go ahead and pause it and go ahead and try this out. If you need help, I'll show the next step. All right, hopefully you've tried this. Now, one thing that you have to take into account for this one is that you will need to use the product rule on the second half. So go ahead and pause it and try from here. All right, hopefully you've done some work. So let's label each individual function part. So we have the log base 3 of x, let's call that k. X squared, let's call that g. And 5 to the x, let's call that h. So label each individual function that you can find. This should help you with doing these types of problems. All right, so go ahead and pause if you haven't finished. All right, those of you who have, well, each of these should have their own derivatives, which we get 1 over the natural log of, that should be natural log of 3. I'll have that edited, times x. G prime is just 2x, and h prime is natural log of 5 times 5 to the x. All right. Useful. Finish if you haven't. All right, those of you who have, your derivative will look something like this. So these two parts are just getting added together, so you'll have the derivative of that part plus the derivative of the second part, which using your product rule is this. And now just substituting in, you get this function right here. Again, this is supposed to be natural log of x. I'll get that fixed in the post. All right. Maximum and minimums. One of the reasons we deal with derivatives is that it helps us find maximums and minimums. So whenever your derivative is equal to 0, then your function is either just constant in that area, it's switching between increasing and decreasing on some other way. Which means it could be going increasing function, but then switches to decreasing, which if you have something like that, that's going to be a maximum. Now, if your function is decreasing and then switches to increasing, well, it goes down, then back up, so that would be a minimum. Now, it's difficult to always know exactly what it's doing on either side, but if you have the graph, or if you just have the function, you'd always tell by putting in numbers from either side of your 0. If it comes out positive, that means it was increasing on that side. If it comes out negative, that means it was decreasing on that side. So you just have to know that if it's changing from the two different directions. All right? So let's look at another exercise. So the cost function for producing X iPods in a day is given by this formula here. Find the number of iPods that would need to be produced to minimize the average cost of producing each iPod. All right, so go ahead and work through this. If you need help, I'll continue in a moment, but try and do it yourself. All right, hopefully you're done, or if you need help, the first thing you should do is find the average cost function. So here's this. All right, so continue on if you haven't finished it yet. Now, the second part, well, let's go ahead and take the derivative. And you all should know that setting it equal to 0 will tell you where your maximums and minimums could occur. All right. Solving this out, we should get 1,500 iPods. Now, how do I know if that's a maximum or a minimum? Well, that's where the calculator comes in. So let's go ahead, turn this on. Now let's go ahead and start typing in our equation. Negative 22,500 divided by, let's go 1,499 squared, close that off, plus 0.01. All right, so that's to the left. Well, that's a negative number, which means it's decreasing on the left. Good so far. Now let's go ahead and change that to a number higher than 1,500. So one thing you can always do is second, enter, and that brings up the very last thing you put in. So if we go back over here, let's change this to 1,501. Enter. Well, that's a positive number, which means it's going down and then coming back up. So this is in fact a minimum. And if you put that into your average cost function up here, that will give you an average cost of 130 iPods, or $130 per iPod, if you produce 1,500 iPods a day. All right. I hope this was informative for you. I will see you in class.